Hey, I'll get into my recording here, and it's so wonderful to be part of this Landsat outreach recording. And thank you for inviting me, Mike. And here I want to talk about something that will help us connect Stella to something that is available to all of us, whether we actually have built a device or not. And that's the whole idea of using ground photos, specifically from Globe Observer, as a way of supplementing what we're measuring through something like Stella, or even larger through our satellite measurements up in space, our multispectral measurements in particular. And so, one of the things that's really important to recognize is seeing the Earth through multispectral information. So how does the sunlight interact with the Earth is the fundamental question. And over the past 50 years, scientists have developed many different tools to be able to do that. And those have been put onto satellites, and they've allowed us to see Earth in a variety of different colors and shapes and ways that are based on that satellite instrument or the instrument that's put on that satellite. Coincidentally, about 25 or almost 30 years ago, the GLOBE program started through NASA's support to try to gather ground information to supplement what we're measuring from space. And the exciting piece about that is it set this foundation of locating yourself on Earth and then making measurements about what we see at that location. And we fast forward and we now have this incredible technology where almost everybody has this sensor in their pocket, right? And so we have this ability where everybody's doing remote sensing, and we want to work together in a way that helps us to understand these satellite measurements. But because of Stella, we can now actually look at the comparison between what we're measuring on our mobile devices in the blue, green, red parts of the sunlight, along with something that's more detailed, something that can be described and can see and measure things that our phones can't or our mobile devices cannot. And that is specifically put together in a way that helps us mimic or simulate what the sensors in space are either doing right now or could possibly do. And so, to me, it's really exciting to think about this evolution in technology and how do we, connect this thing that's happening so far away to what our own experience is. And so, there's a lot of professional evidence here where we're looking at what we're measuring from space. We're making sure that those instruments and sensors are giving us numbers that we expect in places and in ways that we expect them to be. And I'm really glad that I don't have to do that as part of my job. There's a lot of other people that this is all that they do, is spend their time making sure that these numbers are science grade, as it's referred to. And a lot of that goes into calibration or going out and making measurements on the ground in similar ways as what the satellite is measuring. So, this whole idea of measuring what's happening on the ground in a consistent way, and then coming up with equations or understanding what the satellite is measuring is professionals are doing it all the time. And the key is that we have these places on Earth that have been these calibration locations. And they are unique. They've been well described. You can see here talking about how far you can see on the landscape is an important thing. So where I'm standing virtually is not a good location because you can see the shadows that are all around me actually are one of those things that influence what the satellite is measuring. And so here we have an example of the Sonoran Desert where the landscape is flatter. And so you can see that helps us make sure that what we're measuring is all of that sunlight in a way that's a little bit more quantifiable and a little easier to just understand. So, this is the activity of experts and people all around who are professional scientists. And I really appreciate what they're doing because, for us, this is something that's been happening for a really long time. But again, unless you went to a specific school or were funded in a way, had the equipment, you never really got to see the Earth in this multispectral way, in a way that goes beyond our vision, our way of seeing. And this goes all the way back to simulating what we would see with the very first satellite, Landsat MSS. And here, we had 4 cameras that actually got mounted. And here, we didn't have drones at the time. We had to construct a way that we could actually keep this consistent at an elevation that allowed us to simulate what the satellite would look like. Well, again, what's wonderful is technology has gotten significantly better during that time. And now I have a mobile device. And because of the work here with this team, I also have a do-it-yourself spectrometer here that allows me to at least start to understand what am I measuring with the blue, green, red sensor on my mobile device, which you can see behind me. Looks like concrete or grass or something that's very familiar to me because it's a natural color. But you can see on the screen what STELLA and the multispectral measurements are able to do is make it more discrete and to see things again and describe things in a way that helps us to understand how that sunlight is interacting. And importantly here, we have fingerprints or particular spectral signatures that allow us to understand the difference between asphalt and concrete. It's both barren, doesn't have vegetation growing on it, and the way that they reflect sunlight is different, as we can see by both our photos on the ground, which only is measuring 3 wavelengths, versus what we have here with STELLA, which at this point is measuring, I think, 8 to 10. And so, this is a wonderful way. Yes, Mike?
18.
18.
The STELLA Q2, yes.
See, yes. And so this is a really important piece where scientists really need to describe the instrument that they're using, because different instruments, just like our satellites, have and will measure different wavelengths, right? And so here, this is actually a STELLA 1.0 that we're looking at, and it has some different features than version 1.1 or version 2.0, or ones that other people are creating out there that we haven't even experienced yet, right? And so, to me, the exciting part about this, I keep saying that, but you are part of this endeavor in a way that has never happened before. And it starts to become very obvious, right? Well, if I'm looking out at an area and it's blue, well, the blue light is getting reflected up, whether you're measuring that with STELLA or whether you're measuring that with your actual mobile device. And here, what's really great about Globe Observer is it has you sample all of that sunlight that is going around and actually getting measured by something like STELLA. It's not just one measurement or one direction that is being recorded by these devices. It is actually that full area around you. But, we don't have time. We don't have megabytes. We don't have the ability really or the need to have 30 or 40 different photos. We value people's time. And so here we're just asking you to do a sample of where is the sun in the sky? What is the atmosphere looking like between the sun and the earth, similar to what the satellite is trying to look through to see the ground? And what is happening with that sunlight as it bounces off the surface? And the wonderful thing is it gives us a prediction or a possibility of what we might start to see if we go to a more precise instrument like STELLA. And when we start looking across the landscape, we expect green things to have a green hump or to have a particular signature. And these are really known from science, but what we don't really know is what is the STELLA signature of this? And that goes right precisely back to the engineering design of this team and what they've shown. And again, when we do just the spectral sample, when we're in a place where it looks the same, the sunlight still casts shadows. And sometimes they're really small shadows, sometimes they're really big shadows. Again, that is part of what makes that area unique. And where it gets challenging for us scientists and why we need people's help, either doing ground photos and giving us that rapid assessment, or taking that extra time and having a STELLA device on you so that you can make these extra measurements. But, you know, where you're standing in relation to the sun, are there trees to the north or in what direction? All of these things end up affecting what a satellite way up in space, 700 kilometers up there, might actually be reading as well. And so what's important to recognize is you're already doing this spectral sample that we can start to understand how that sunlight is interacting in that area. Now, you might ask, well, is this really helpful? Well, it all depends on how good the photos that come to us are. If they don't have a lot of detail, no, they're not very helpful. But just like our satellites, our mobile devices have gotten better with resolution. And also their sensors have evolved over time. And so we expect that to continue happening. And so, you know, the spectral measurements you might have made on a mobile device 3 years ago might actually be different than ones that you're making today. And that's all part of what we're experiencing with the STELLA evolution too, from 1.0 to 1.1 to 2.0 to probably 3.0. So pay attention to these specifics because they really get back into what those numbers mean. And numbers can mean something on their own, or they really need to be made relative to something else. And that's where calibration or describing 100% reflectance, right? Add something down here so that we know those numbers and it's consistent throughout all of our imagery. That would be a way of taking an extra step and starting to standardize a ground photo even. But when you do STELLA measurements, you really need to be kind of thinking about all of this sunlight. And here I want to show you, you know, just the quick variation in down photos that we see from the upper left, where we have sunlight with some new snow from Colorado with a lot of air mixed in. That's really, really bright. And just like this photo, the numbers for STELLA are off the charts. And we can see as we go through, different land cover on Earth gives us different colors. And we see that in these photos. It's really obvious. It's one of those things why it's not just a black image or just a white image, right? We're getting some of that spectral reflectance going on there. And I want to highlight in particular the lower right photos, which actually are showing two different types of snow on there. And really there, what I was trying to do is demonstrate how, yes, it's snow, but the reflectance amount is impacted by the dirt, or as some scientists refer to it, as the cleanliness of that snow. And that's one of those characteristics at the very high end of our reflection that we can use to understand snow dynamics and how it changes over time. And usually if you have to put your sunglasses on, that STELLA measurement is going to be really bright, as well as your photos. So all of this comes together in a way that at least gives us some understanding of what we might expect from satellite measurements from this quick rapid assessment like this. So I want to highlight how, again, there's a lot of information that scientists and other people have learned over the years. And here, what we're sort of wanting to move towards is looking at how seasons change and how these ground photos might go from green to brown as leaf conditions change on the ground, like for a deciduous forest. And all of these things go back to our spectral measurements. And one of the things that gets really interesting is when you add snow to these dark pixels, how obvious it is. But this mixing of different material like this, wetness, all adds to the differences that you will have when you make your measurements, just like you see with these images, these ground images that we have here. So this is the fundamental piece where we're really trying to put the scientific tool and way that we see the world, which is multispectral, into the hands of other people so that it's not just the elite scientists who have the resources, but actually all of us have the ability to see the world through this spectral lens. And so, there is the other piece of why we want to use Globe Observer, because we have a specific protocol within there that focuses on the sky conditions. And recording that is vital to understand why you get the numbers that you are. And so let's work together to try to understand the sunlight on Earth. I was really excited for this April 8th, 2024. Yes, example of the solar eclipse that came through that gave us the opportunity to actually see in the bright light of day the influence of the sunlight and the moon and what happens, when that sunlight actually goes away or is blocked or obscured in some big phenomena like we're able to see here on this animation because of the satellite images that were getting measured way out in space. Same thing as STELLA. It is all reflectance of sunlight on Earth. And it's amazing the insights that we can get. So I hope that you join us in this endeavor by making a STELLA of your own and making those measurements, but add in the context using some ground photos or using a protocol like Globe Observer. Even if you don't have a STELLA, you can use that as a rapid assessment to give us that understanding. Is it more blue in this location? Is it more green in this location? Or is it more red because of some reason that you can explain to all of us? So I am really excited that STELLA has come onto the scene here and has really taken something that is so far away and put it into the hands of all of us here. So thank you very much to the STELLA team for all that you have done and continue to do. And I'd love to take any questions that might have come to mind or come up as we were talking.
That is amazing. Thank you so much. Thanks. Let's see. Do I have any questions for you? What other things do you think we could use STELLA, say, with and Globe for? I think I was hearing something from Cassie about possibly mosquito mapping.
Yes. And all of this goes back into what are the environmental characteristics that go into different habitats. I mean, one thing here that I think is really an obvious and fun one is going out on at least a monthly basis and making a measurement at a particular location in that down photo. And it's basically a 1 meter area that you are taking a picture of, and your STELLA measurement is at 1.5 meters off the ground. And so it really gives you that area. And as you can see on the photos here, you will see an evolution of phenomenon in this location. And even if it's something like asphalt, the sun angle will most likely be changing in your location. So all of a sudden we have to start thinking about, well, where's the sun in the sky? And am I getting the same amount of sunlight in December as I do in June? And if I don't, well, of course I shouldn't expect the same numbers, right? Mm-hmm. And so this idea of where the sun is at in the sky really is crucial to understanding those numbers from STELLA. And it's, to me, that it's a wonderful way of connecting yourself to these measurements and thinking about and being part of the amount of sunlight that hits an area and how that might affect things like snowmelt, right, over time, and watching the snow go from a solid state into a more liquid state, into a liquid moving state, and even what I'm showing here in the second to the left frame there is a hot spring where we're actually seeing their hot water boiling off. And so we have the full spectrum here of water in its different phases.
Now, quick question here. I did see a thermal on there, perhaps like a thermistor.
Yeah.
Would we be able to do some, say, UHI or anything with that? That was a question from Alex over here.
Exactly. No, that's exactly what I've been testing out. And so far, I mean, this was the whole reason why I wanted to do this right here, is this was for the urban heat island effect. And right now, there's a lot of maps that are telling us that this area is barren or it's developed. But this difference between concrete and, as you see here in this picture, it's 38 degrees in part because it's weathered. It has dirt on the top of it, right? And so there is going to be maybe a difference with younger or more clean concrete that's more white. That might react a little bit more like snow does. But that was one of the things I really liked about the STELLA version 1.0 is that it had a thermal measurement on there for surface temperature that simulates the thermal measurements coming from something like Landsat. But it also had an air temperature piece. And so it allowed me to distinguish that difference between the two. And you can see clearly here, there is a difference, not only in the spectra, but also in the measured measurement of the thermal emission coming from this. And that is what really got me excited, because that's what the Landsat has been doing. And so, again, that's one of those things that, yeah, I have a fancy camera that I can plug into my mobile device, but it costs a lot of money to be able to do that. And to be able to have this instrument that not only records the thermal measurements, so that skin temperature of the Earth there, but also all of those other spectral wavelengths, it's exactly like what I'm seeing from space. And so it allows me to really start to understand, when I see these numbers in the satellite imagery, this is what it could mean. And it's all, here, you could do this without caring where in the world it's located, right? But where Globe Observer really comes in too is it helps you locate where this is happening in space, in the world, so that you can actually then go find, well, did the satellite measure something similar? And or is there a difference, between one location or another location? And so, I love what STELLA has been able to give us, because you can just focus on the spectra, do lab experiments with that, look at different rock types, and see what those numbers are. But really, the extension is taking it out into that field and seeing what is happening on a day-to-day basis. And it really is important for you to think about, well, what measurements do I want to make, right? Because STELLA 1.1 has a LiDAR on it, a laser distance device that allows you to know exactly how far off that material you are making your measurement. And again, that can be used to profile the variation in height of your surface, just like what we have from the International Space Station and JEDI, or ISAT-2, or some of those different ways of really understanding our landscape. So, I've learned, just like our NASA satellites, we have options available to us. And then, there's the Q2, right? And that has a different way of measuring similar characteristics, but it's a different device. And so, again, numbers can be numbers, but what they really mean go back to understanding the instruments, how it was designed, this field of view is a really important concept to get down, which is another reason why I recommend adding a photo to what you're recording, so that when you go back and you're looking at your numbers, you have some sense of what those numbers were actually recording, right? Numbers are just numbers without place and without meaning.
We had another question from Matthew Pierce over here asking about like he knows that there's a air quality one. Could we use that, say, with like the thermal to like measure some particulates and the airflow as well
Exactly.
when we're
Yes.
looking at the UHI?
Yes. And for me, that's this piece where in space, we've had to prioritize one instrument over another instrument over another instrument. And so then it takes scientists on the ground putting this all back together to really understand the profile and what's happening in the air versus what's happening on the ground, and the interactions between all of that. We have different satellites that are moving around, and we try to get those coincident measurements. But what STELLA really gives us the ability to do is simulate what it would be like if we were able to make a full suite of measurements across the electromagnetic spectrum, that allowed us to see not only these particular wavelengths, but go beyond this to more what we can see, the gases like CO2 or methane or other things like that, which scientists have to correct for when they're making their measurements. And so it is something that we're measuring between our sensor here and the ground. It may not be a huge column, right? It's only 1.5 meters compared to 705 kilometers up to the one up in space, but there's still air there. There's still influence, and that's part of what is causing all that sunlight to bounce around in the way that it does. And so, yeah, so let's try to see what other instrumentation we can add on to STELLA and really, get those coincident measurements and use the electromagnetic spectrum to our advantage for all of these things.